Hi everyone, this is Rupesh and you are watching CBBNet's video series on data structure and algorithms, and this video is about printing a right view of a binary tree. So if you already know what is binary tree, that is good. If you don't know, you have to see what is binary tree. And before this, I have explained how to print a left view of a binary tree. This video is sponsored by Visual Assist, the well-known productivity extension for Visual Studio and Unreal Engine 4. Visual Assist speeds up development with features like smart navigation, code inspections and suggestions, powerful refactoring commands, debug assistance and a whole lot more. Even spell checking in comments. Visual Assist is written by C++ developer for C++ developer. Start your free trial at wholetomato.com. We think you will be pleasantly surprised by what Visual Assist offers, and in the small touch that turns good features into great ones. Link is given in the description field. So the idea is we will do pre-order traversal. So pre-order meaning you will first print the node and then you will go to either left or right? But as we are going to print the rightmost node in each and every level, you should go for right first and then left. So this is for printing and this is for traversal. Okay, these two are for traversal. So if you don't know what is printing right view of a binary tree, then understand this. You look at this tree from this side, okay? So your eyes are somewhere here. I'm very bad with the drawing now, okay? So what you can see is this one, this one, this one, this one, and this one. You cannot see 6, 5, and 3 because they are coming behind this 7 and 4, okay? So we'll achieve that with the help of this pre-order traversal and two variables. One is max level and another is current level, okay? Initialize this max level with 0 and current level, let's suppose 1. And the idea is if you are going right hand side, meaning initially you will come here and then from here you will start going right because this is like this. First you will print. So let's print this. And yeah, the output of this should be like this: 2, 4, 7, 8, and 9. Okay. So it's like we are printing this one, this one, this one, this and this. Okay. So you came here, you printed this just because we will print first and then we'll go to the right. Okay. So you printed this 2. So let's suppose we have printed 2 and this is done. We'll go right. And the moment you reach right, you will do again the same thing like P, R and L. So you will print this first and then you'll go here. Okay. So each and every node you will do P, R, L, P, R, L, P, R, L. So you printed this, you went to right. You printed this, you went to right. You will again print this. So you'll print 7 and you'll try to go to right, but there is no right here, right? So you'll try to go to left because left is left. So you will not have anything in the left hand side also. So you'll go back from here to here. Once you will reach here, because it is recursive, so you should know how recursion work. So as this is recursive, you will go back because the whole stack is over here. Once you are done with the right, you will go to left. So you'll try to go to left, but there is no left here. So you are done here also, you'll try to go to this location. And now you see, when you was here, you did print, you did right. And what is left? Left. Going to the left is only remaining, okay? So you'll go to left here now. So again, P, R, L. So the moment you reach here, this is the catch. When I was coming from here to here and here to here, what I was doing, I was checking if my max level is less than current level. So initially as I put this is true. So once this is true, I'll print this. So I was printing it. The moment I go to this location, what I did, I will increment my current level because my current level is increasing and I had updated max value with 1. So max and current was like this here. Initially it was 0 and this was 1, right? Due to this condition and you reach to this. Now the condition is if current is greater than max, then print and assign max equal to current. This is what you will do. So here we found that true because current is 1 and it is greater than max level. So we'll print that. So we printed it. We'll go to this level. The moment we reach this level, we would have incremented this current level because when you are going from here to here, you are actually incrementing the level. You are going down the levels, right? So now your level is 2. So current is 2 and max level is 1 because we had initialized 1. So this is again true. So we'll print this and then we'll make this max level is equal to 2 now, because that's what we'll do. So we printed this again, and now current is 3 when you will go from here to here, because we incremented this current and this max was 2. So similarly, again this is true, you will print this 7. So we printed this 7. Now try to understand this. The moment you are going back from here to here, your max value will retain same, whereas your current will become -1. So here your current is 3, but here your current is 2, and here it is 1. Okay, so this is 3, 2 and 1. So this is current value, but the max will retain its value. So maximum you could go is 3. After this you will initialize this into 3. So you will make maximum is equal to 3, but current will actually keep changing, because if you're done with this stack, you will go back here and then current will become 2 now. Okay, and then once you're going back from here to here, current is 1 now. But here, as you are back from this whole right traversal, max is changed. Max is 3 now here, because you have done from this part. Okay, the moment you go from here to here, the same rule will apply, this if. So now from here to here, your current will be 2 because this is 1 now, and from here to here you will go and then current will become 2. And remember, max was 3. Is this true? No, it is not. Then you will not print this. Okay, so this printing statement will not happen. So you will go from here to here. Again, you will apply P, R and L. So you'll try to print, but printing have this if condition. As you are going from here to here, your current is becoming 3 and your max is also 3. So this is not true. Your current is not greater than 3 because it is equal to 3. So you will not print this. You will try to go to right, there is no right. You will try to go to left, there is no left. You will go back from here to here. Now you will go to from this place to this place. Okay. So again, if you're going from here to here, this is like 3 and 3 because your max is 3, your current is 3. So this is not satisfying this condition, so you cannot print it. So similarly, P, R and L, but you cannot print it. Here also you could not print, and right and left was done. And here could not print, you went to right, you came back, and then you have gone to left, and then you could not print because this is equal. The moment you go from here to here, see what is happening now. Current is becoming 4, whereas max is still 3. Okay, max is 3. Now this condition is true. So 4 is greater than 3. Now you will go and print it. So you'll print 8 now. See, we have printed 8 and this is the actual output, correct? So we'll print 8 now because this is true. And now you'll make max is equal to current. So max will become 4 now. Okay, because max is like a global variable. You maintain it globally kind of thing. Okay, we'll see how we'll maintain that in our programming. But consider this as a global. Once it is done, it is done. It is not associated with any stack. But whereas this current is associated with the stack. So here current is also 4. Now max also became 4. Okay. Now you're going from here to here because you tried to go to right, but there was nothing. So you will go left. Then current will be 5 and your max was 4. Is current greater than 4? Yes, it is. Then you will again print. So you'll print 9 also. So see, 2, 4, 7, 8, 9, 2, 4, 7, 8, 9. You tried to see this from this direction, 2, 4, 7, 8 and 9. This is how you'll do it. And if you really don't understand how I'm talking about these recursions and stacks and all that, so it means your basics are not clear. You should go and watch my videos where I talk about binary tree traversals. So you should be very clear about the traversing, then only, you will be able to understand this better. So let's show you the code now. So this is your helper function. Assume that you are calling this with root, which is your root of the tree, and max level like 0 and current level 1. Okay. So if you're calling this function, you can call it like this. You have helper and root, comma 0, comma 1. This is how you'll do it, and you will end up printing 2, 4, 7, 8 and 9. So this is your output, 2, 4, 7, 8, 9. Let's see how we'll do this quickly. If root is null, we'll just simply return from here. Otherwise, see, current value is greater than max value. Yes, it is, because max is 0 and current is 1. So we'll print this. So initially we'll print root, meaning we'll print 2. And then max level is initialized with current level. So now max is also 1 and current is also 1. Now see, this is very important. You are going to the right first and then left. Okay, so you will go from here to here, and see, we are incrementing current level plus 1, and max level will go just like that. And I told you, right, you have to maintain this max level as a global variable. You can do that with the help of this reference, because if you are passing or taking this variable as a reference, meaning you are pointing to the same variable all the time, irrespective of which stack you are at. Okay, but here if you are passing this current value and then current value plus 1, meaning if it is 1, then 1 plus 1, 2 is going from here to here. And if you're going if you're coming back from that stack and going to hit this line, meaning current value will point to 1. Okay, so this is very basic. If you still didn't understand, what I mean is, see, currently at this location, at this point, when you reach with this 2 in the root, current value is 1, right? But we are again incrementing it with 1 and passing 2 from here to, again, calling the same function, right? We are calling the same helper function. In that case, here max level will come as 1, but current level will come as 2. But that is okay. That is not the point. The point is, let's suppose you went from here to here and then you completed all these things and you came back, and then the moment you are coming back from here to here, meaning you are actually reaching back to this line. Okay, because you called yourself, so you go from here to here again in the loop, right? Like you are calling yourself again and again until unless you are done calling right, then you will go for left. Okay, but the moment you are coming back, in that case, this temporary variable which got created because of that new stack when you go from here to here will get destroyed. So the moment you are coming back from here to here, whatever this current level was holding the value at that time would still hold that value only. Okay, but as this is reference, when you are passing this reference, you are actually passing the same variable what you was having at this level. Okay, so if you're passing the same variable, you are not creating it again. You are just pointing to the same variable. But here in this case, in each and every call stack, you are creating a new variable. Meaning, if you will go back in the stack, you will always have the older value, older current level variable. But this is always going to treat as a global variable because it will not change if you are coming back from stacks. Okay, I hope I have explained this basic thing pretty deeply. So, okay, so we were going from here to here, right? So now max will be 1 and current will be 2 from here to here. Okay, the moment you are coming from here to here, root is again not null. You will see current level is again greater than max level. Yes, it is true. You will end up printing 4. And similarly, you will go from here to here. Then in that case, it will be like 2. And this is going to be 3. Then again, this is going to be true. You will print this and we'll go all the way back because we don't have any left of 7 or left of 4. So you will reach here. Now notice current value. So when you're coming back from all the stacks, in that case, at this location, you will go from executing this line to this line. Okay. And in that point of time, your max level would still be pointing at 3, but your current level when you went from here to here was only 1 because we passed 1 when we call this function, this function here. So we passed 1. So that time current value was 1. So for that only, it will be 1 only. So now you're passing, calling this one. So current value is passed as 3, max value is passed as 3, but current level is passed as 1 plus 1, meaning 2. So here it will be like 2 and 3. 2 is not greater than 3. It will not going to print. Here it will go. Here it will be like 3 and 3. It is not going to print. Here it will go. It is like 3 and 3. It is not going to print. Here it will be like 4 and 3. So this is your current and this is your max. So this time it will print. So it will print 8. Here it will go. It will be like 5 and 4. So here also 5 is greater than 4, meaning current is greater than max. It will print 9. So like this, it will print 2 and it would have printed 4 and 7. And now it is printing 8 and 9. So this is how this whole recursion will work. I hope you have understood it well. If you have still some doubt, you can comment. I'll try to help. Bye bye. Take care.